Hi everyone, this is K. Karthik from Institute of Aeronautical Engineering from EEE Department Section A 23951A 206 is my roll number. Now I am going to discuss about how to maintain object-oriented program. As per my information, as the name suggests, object-oriented program or OOPS refers to language that use object in program. They use object as primary source to implement what is to happen in the code. Now I am going to explain about maintaining object-oriented software. As per my research, object-oriented program has access modifier, the return type, method name, parameter list, exception list, method body. Introduction. This presentation will explore best practices for maintaining object-oriented software to ensure longevity and robustness. Understanding object-oriented design. Object-oriented design is a paradigm that focuses on creating reusable and modular code. It promotes encapsulation, inheritance, polymorphism, and for flexible and maintainable software. Object-oriented design (ODD) is a process of using an object-oriented methodology to design a computing system or application. It involves modeling real-world objects as software objects with properties and methods that represent the behavior of those objects. ODD uses this approach to design and implement software systems. Design patterns are also used in ODD as reusable solution to common problems in software design. Refactoring is the process of restructuring existing code without changing its external behavior. Techniques such as extracting method, rename variable, remove duplication, and can improve maintainability and readability. To understanding object-oriented design, you need to know some basic concepts and principles of object-oriented program. Object-oriented program is a programming paradigm that relies on the concept of the class and objects. A class is an abstract blueprint and creates more specific concrete objects. Classes often represent broad categories like car and dog that share attributes. These classes define the attributes and instance of these types. Will have like color but not the value of those attributes. For a specific object, classes can also contain functions called methods that are available only to objects of that type. These functions are defined within the class and perform some action helpful to the specific object type. Testing strategies. Comprehensive unit, integration testing, and regression testing are essential for validating and functionality and stability of object-oriented software. An object is an instance of a class that represents a specific example of the abstract abstraction class, like my car or golden retriever. Each object can have unique value of the properties defined in the class. For example, say we created a class car containing all the properties a car must have color, brand and a model. We then create an instance of a car type object, my car to represent my specific car. We could then set the value of the properties defined in the class to describe my car without affecting other objects or the class template. We can then reuse this class to represent my number of cars. The four main principles of OOPS are encapsulation, abstraction, inheritance, and polymorphism. These principles help to create software systems that are modular, reusable, and easy to maintain. Dependency management. Effective dependency management involves minimizing coupling between modules and using dependency injection to promote loose coupling and high cohesion. Encapsulation means that an object's data and behavior are hidden from the outside world and can only be accessed through a defined interface. This helps to protect the object's integrity and prevent unauthorized access or modification. Abstraction means that an object only exposes the essential features and hides the unnecessary details. This helps to simplify the complexity of the system and make it easier to understand and use. Inheritance means that a class can inherit the attributes and methods of another class called the parent or superclass. This helps to avoid code duplication and create a hierarchy of related classes. Polymorphism means that an object can behave differently depending on the context or the type of object. This helps to create flexibility and dynamic software systems that can handle different situations. Object oriented analysis and design OOAD is a technical approach of analyzing and designing an application system or business by applying object-oriented concepts and techniques. OOAD involves a number of steps and practices utilizing a version control system such as Git with a well-defined branching strategy and pull request workflow can facilitate collaborative development and ensure code integrity. Object-oriented analysis and design OOAD is a technical approach for analyzing and designing an application, system, or business by applying object-oriented concepts and techniques. OOAD involves a number of steps and practices such as identifying the requirements of the system and the user's needs and expectations, creating use cases to describe the different ways in which users interact with the system and the expected outcomes, creating UML diagrams to represent the different aspects of the system, such as the classes, objects, relationships, behaviors, and interaction, applying design patterns to help solve common problems in software design and improve the quality and efficiency of the system. Implementing the system using an object-oriented programming language such as JavaScript, C++, Java, or Python. Comprehensive documentation includes API references, code comments, and user guides is crucial for maintaining software knowledge and facilitating onboarding. Performance optimization, identifying and addressing bottlenecks through profiling and optimization techniques such as caching and parallel can enhance the performance of object-oriented software. Implementing security-based practices including input validation, authenticator and encryption is essential for safeguarding such object-oriented software against vulnerabilities and attacks. Continuous integration and deployment, leveraging CI or CD pipelines to automate builds, testing, and development can streamline the development process and ensure consistency and reliability of software releases. Adapting to technological advancements, staying abreast of emerging technologies and frameworks is essential for evolving object-oriented software to meet changing requirements, capabilities, and leverage new. Conclusion. By adhering to these practices, software developers can ensure the longevity and robustness of object-oriented software, enabling it to adapt to evolving requirements and technological advancements. Thank you.